let's get started. And if you see me fall, don't worry about it. I'll get up and continue. Alright. So we talked about some basic shapes. We talked about triangles, properties. We talked about parallel lines. We talked about what is opposite angles and all those things, right?
Yes.
So we have just talked about the property of the shapes, and that is going to play a very important role when it comes to dealing with geometry. So that's why I'm just checking if it's recording. So next we go to quadrilaterals. Is anybody here? Is somebody with you?
Oh, it's just my mom. She's in the car.
She's in the car. I mean, if she wants, she can sit inside. I'll close the garage door so the heater works. Or it's okay?
I think she's fine.
She's fine. Would it be okay if I close the garage door?
Yeah.
Okay. So yeah, just tell her to be comfortable, okay? You are with your parents right now. I'm like, just tell her that, no? If she wants to come inside. She can see what I do in the class, if she wants.
Okay, yeah, I think she's fine in the car.
She's fine. Okay. So we looked at the property of shape with three sides and three angles. Triangle, that is where we talked about. We categorizing them based on sides and angles. That is where we talked about sides, where we have equilateral, isosceles, and scalene triangles. Yeah? She's comfortable?
Yeah.
Yeah. Okay. And then when it comes to angle, that is when we talk about three types of triangles again. Triangles with all smaller angles, all acute angles, acute angle triangle. Triangle with one angle is 90 degree, that is right angle triangle. And then triangle with one angle more than 90 degree, that is obtuse angle triangle. That is the property. Now, and then we talked about one formula, one magical formula which says sum of all the angles of any polygon is 2n minus 4 into 90 degree. Yep.
And then that's for how to find.
Any polygon. So let's say if I'm talking about triangle, sum of all the angles, I will put n equals 3. So 2 times 3 is 6 minus 4, that is 2. 2 times 90 is 180.
Oh, okay. Oh,
If
so
I'm-
that's like the total.
Sum of all the angles within a polygon.
Okay.
So if I'm talking about a quadrilateral, 4 sides, 2 times 4 is 8. 8 minus 4 is 4. 4 times 90 is 360. Sum of all the angles of a quadrilateral is 360. Okay? So this is anyways, as I would call it a sidekick. Let's move on. So now we are talking about a quadrilateral. It's a family of shapes which has 4 sides and 4 angles. Now in that family you have rectangle, square, parallelogram, rhombus, kite, and trapezoid. Total 6. So let's look at the property of these shapes and then we'll jump on to finding out the area and perimeter of these shapes. And you will find that information quite handy as long as we are clear with the property of it. So first is rectangle. Rectangle has opposite sides equal and parallel to each other and every angle is 90 degree. Square. So this is rectangle and this is square. Square is another type of rectangle where you can say where here only the opposite sides are equal and parallel. So this and this equal and parallel, this and this equal and parallel. Here all the sides are same and opposite sides are equal and parallel too. And every angle is 90 degree. Rectangle and square. Next one comes as a parallelogram. Parallelogram is another flavor of a quadrilateral where opposite sides are parallel and equal without a caveat of all angles being 90 degree. So parallelogram is a superset. When you are saying opposite sides are parallel and equal. Okay? So if you look at carefully this guy and this guy, both are actually parallelogram.
Because both.
Opposite sides are equal and parallel. So here also opposite sides equal and parallel. If within a parallel, so parallelogram is a wider set. where if the angles are 90 degree, you will call it a rectangle. If they are not, they'll just remain as a parallelogram. So parallelogram covers all the types of quadrilaterals where you have opposite sides equal and parallel. Yeah? Alright. Now, is a square a parallelogram?
Yes.
Yes. Because your only criteria for somebody being called a parallelogram is opposite sides have to be equal and parallel. Here the opposite sides are equal and parallel. No denying that. Whether all the sides are same or not, that's an extra information you have. Yeah? Now, so this is parallelogram. So we looked at rectangle, square and parallelogram, property wise. Okay? Now, let's look at the next shape, that is a rhombus. So the way I always define rhombus is, it's a squeezed square. So you had a square, you pick two corners of it and you squeeze it. So the length of the side remains the same, but here in case of square, all your angles were 90 degree. That is not the case anymore. When you squeeze it, it becomes thinner
So
and
the
taller.
obtuse? Kind of?
Obtuse, acute, both. Because see, when you are pressing it from here, when you are squeezing it from these two corners, right? Here it will expand. It became bigger than 90 degree. This is greater than 90 degree. Wherein the other two corners which were not touched, they became smaller. So imagine, I know I'm forcing your imagination here, but I had a square. I picked two corners, two opposite corners, and I squeezed it. What happened was, it expanded vertically. So here it became thinner. On these two corners became thinner, and here it became wider because the sides got pushed this way.
Okay.
I'm not trying to do any exercise right now. I'm just showing you. I'm just helping you visualize this. Okay?
Yeah.
Yeah. So here, when you were pressing it, on those two corners it became wider, bigger than 90 degree. So I would not say that rhombus has all the angles acute or obtuse because you have both the flavors of it. The two opposite corners are acute, these two corners are obtuse. And then there's one more interesting property of a rhombus that we need to be aware of. When you make it a rhombus, the two opposite corners are called diagonals. When you join the two opposite corners, they are called diagonals. Okay? And they play a very, very important role. Because the interesting property of a rhombus is these diagonals meet each other at 90 degree and they perpendicularly bisect. So
And then they make right triangles, right?
exactly, that becomes your rule for finding out the area here. So basically, if you have to find out the area of this rhombus, that will be equal to 4 times the area of this right angle triangle. Okay, and then the next shape is, so this is rhombus, and next shape is kite. I'm not sure if you got a chance to fly a kite ever. You guys are not privileged like we were.
What?
It's a kite. It's like made of paper, and you put a string to it, and then we used to fly that in the sky.
Yeah. I flew a kite.
Your kite, wonderful. So here it's also a quadrilateral because it has 4 sides and 4 angles. It will look somewhat similar to the rhombus, but little different. As in case of rhombus, since it's a squeezed square, so all your sides are of same length. Wherein in this case, only the top 2 sides are same, the bottom 2 sides are same length. Okay? It will look somewhat similar to this guy, but with a different property. Here also, you can look at this property. These two diagonals meet each other at 90 degree. They are perpendicular, but they don't bisect because it's not symmetric.
Wait, what do you mean by bisect?
Bisect meaning split into 2 equal parts.
Oh, okay.
Yeah?
So for the kite, it doesn't do that?
It doesn't do that. Here, because see, the problem here is that the top and bottom are a mirror image of each other. In this case, it's not the case.
Oh, so when something bisects, it has to be a mirror? Like, it
Yeah.
has to like be the same?
It has to be same. It has to be symmetric, right? So here, you see that this side and this side are copy of each other, but top and bottom, if you see, the bottom portion is longer, top portion is smaller. Yeah.
Okay.
So they meet at 90 degree, but they don't do they are not perpendicular bisector of each other. If I ever say use the term perpendicular bisector, what I mean is they are perpendicular and they are bisecting into two equal parts. So in this case, the diagonals are perpendicular bisector, meaning they are meeting at 90 degree. At the same time, they are also splitting each other into half. Okay. So when you are looking at these two shapes, I will not go to trapezoid right now. Let me close this thing here. Now let's look at it. I know I might sound kiddish, but this is part of the journey. So if I have to find out the area of rectangle, length times width, you know it.
Yeah.
That's why I was calling it kiddish, but we relate to that. Okay. So length times width is the area of this guy. If somebody says find out the perimeter, how much that would be?
You just do length.
Length of the boundary, right?
Yeah.
So again, your opposite sides are equal and parallel. So 2 times the length and 2 times the width. That will be the total this thing. So that's why I was relating to the property part of it. Okay. Now if I'm talking about perimeter of this guy, all the sides are same. So 4 times the length. That will be the perimeter. Area, again I'll use the same formula, length times width. My length and width are the same. So that's why it becomes, if I'm calling this as a length, this will also be length. So here the area is length times width. My length and width both are same.
Yeah.
So length square. Now coming to parallelogram. Okay. Here I will not talk about how the okay, let me give you a pictorial view of this. This was a parallelogram, okay? What I did was I dropped a perpendicular from here onto this line and another perpendicular from here to here. Okay? So if you visualize this part, this is a rectangle because this is perpendicular, this is perpendicular. Yeah? This one.
Oh, so you have 2 right triangles. And if
You have 2 right triangles and they are exactly the same copy of each other. So if you have to find out the area of this guy, this will be equal to the area of this guy. Okay? And here it is length and this part is, I'll not call it a width, I'll call it a height.
Yeah.
So that's why the area of parallelogram is base times height.
Base?
This length I'm calling it a base because there's nothing called length and width here, right? So if you flip this parallelogram like this, and you're looking at it from this side, yeah? I mean, imagine me sitting here and then visualizing this parallelogram, okay?
Okay, yeah.
So this is my, shall I call it length? Shall I call it width? To clear off all the confusion, we are calling it the base. So base is where it is sitting right now. So here, right now this parallelogram is sitting on this side. So I'm calling this the base. If I look at from this side, this will be the base. So overall area is the space taken by this, whether you're looking at this in this angle or you flip it, rotate by 90 degrees and then you're looking from this side. Space that you take will be the same, right? So you don't say length or width, that creates confusion. So you'll say, okay, from whichever side I'm looking, I'll take that as the base. Okay? So somewhat similar to rectangle, length times width, but here you don't call it length or width, you call it base. So whichever you pick for this parallelogram to rest on, that becomes your base and then the height. Okay? And if you're looking at it from this side, if you take this as a base, what will be the height? You will do the same thing. You'll drop a perpendicular, find out this height. Yeah? Is that okay?
Wait, what?
I'm saying if I take this as a base, this will be my height. Height is the distance between the 2 parallel lines.
Okay.
Yeah. So parallelograms area is base times height. Alright? I'll give you 10 seconds to digest this before I continue.
You know how like in the equations, it's either like you use a small b or a big B? Like, you know?
Yeah. No, so that, I mean, whether it's small b or big B, you'll not care much about that. you'll only look for what is my base. So let's say if you are given a picture like this and you have to find out the area of the parallelogram. Okay, and you are given this length, let's say 12 centimeter. So the next thing, if you have to find out the area of this guy, you have to find out, okay, if this is the given, that means I have to find out this is my base. What is my height? Where is the height given to me? Okay, so you will look for this height, the distance between these two parallel lines. If you are taking this as a base, there is a line parallel to this, and the perpendicular distance between the two lines is what will be your height. Okay, that's what you look for. Sure? Clear? Okay. So this is rectangle, square, parallelogram. You are able to find out area and perimeter just by knowing the property of it. Now let's come to this guy, these two guys. As I said, in case of a rhombus, the diagonals, let's say this is D1, here to here is D1, okay, this is the length of the diagonal, and here to here, second diagonal is D2, okay. So what I said was, these diagonals are perpendicular bisector, meaning they are splitting this whole rhombus into 4 equal parts. So if we can find out the area of this triangle, I'll just multiply that by 4, that is my area of a rhombus. Yeah. So 4 times area of the triangle. Okay. Now let's look at what is the area of the triangle. This is right angle triangle. What is the area of triangle formula? Area of...
Wait, isn't that just Pythagorean theorem?
No, I'm talking about the formula for area of a triangle.
Oh, is it 1/2
base into height?
base times height?
Okay. Don't think about anything that is stressing you out. Okay. You are my child. Okay. So you have to be very comfortable. So if you say something wrong, I'll correct it. Don't worry about it. Don't doubt yourself. That's my request to you. Okay. So half into base into height. Very simple. You know that, right? So half into base into height. Now half into base. If this is my base, this is base, it will be half into base. This base is what? As I said, these diagonals are perpendicular bisector, meaning they are meeting at a point where they are bisecting each other. That means this length will be half of this whole length, half of D2. Yeah, this length, base is half of D2. This is D2, this is diagonal 2, half of the diagonal 2. Yeah, so half base, this is my base, half, which is half of the diagonal, into height. Again, this height is half of the second diagonal. So that is D1 by 2. Am I making sense? No, it's okay. So so I'll create some real estate here. Then we can relate to it. And as I said, I don't get tired if I have to explain something. I take pride in when I see a smile on my kid's face. Okay? So look at this. This is my rhombus. Okay? Starting from the beginning. All the 4 sides are same. This is, let's say this is length, 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 and length. Because we squeeze the square, so sides length remain the same. And the next property that we talked about was these two are diagonals. They are perpendicular bisector of each other, meaning wherever they meet, they split each other into halves. So if this was my length of the diagonal, this was my one diagonal, let's say this is D1. This is my second diagonal, D2. I'm just, maybe I'm not drawing it right, but this, I'm talking about the distance between these two. Okay? This is D2. Now what we're trying to find out is area of this triangle. And as we can see pictorially also, the side area of this triangle is 1/4 of the whole thing. So once we find out the area of this triangle, we'll multiply that by 4, then it will give me the area of the rhombus. Okay? So now area of this triangle, this is half into base into height, as you said, correct?
Yes.
Now let's look at how much is the base. Half, okay, base. I'm calling this as a base, okay? Yeah?
Oh, so say you're trying to solve area
Of this
When
triangle.
we think about base, we think about the whole triangle. But since we're only looking for that one,
Oh, I'm only looking for the shaded one, right?
okay.
For this triangle, this is my base, which is half of this whole distance, and this whole distance is d1. So half, this is my half, and how much is my base? I will write the base. This base is half of the whole distance, which is d1 by 2. Yeah? Into height. This is the height. Sorry, this is my height, my bad. This is my height, right?
Yes.
So this is height. This is what? Again, half of this whole thing. d2 by 2. And if you need water or something, let me know. Okay? If once we calculate this thing, that will give me the area of this triangle. Now, if I multiply this whole thing by 4, whatever I get here, if I multiply by 4, I will get the area of the rhombus. Yeah?
Wait, can we use some real numbers?
Okay, so let's say this is, okay, we'll do that. We'll do that. Let's say this is d2 is 20 and this d1 is 10. Is that okay?
Yeah.
So what will be the length of d1? This one's 10. So this will be what? d1 by 2, d1 by 2, which will be 10 by 2. Yeah?
Mm-hmm.
If I'm talking about half into base, this is my base. Now I'm talking about the height, which will be again half of this whole thing. d2 by 2. d2 is my 20 by 2. Yeah? So that will give me the area of this triangle. Okay?
And we're dividing by 2 because the right triangle is like split. Because there used to be a whole triangle.
Right, so I'm only looking at this thing, okay? So, let me break it down. So, forget everything. Look at me now, okay? So, everything, just wipe it out from your mind right now.
Oh.
If I have to find out area of a triangle, what do I need? Base into height. Half into base into height. That's what I need. Okay. Don't even imagine that this is part of this rhombus. You just say, okay, this is a triangle I have, and this area of this triangle, like we always do, will be half into base into height. What is my base? This one. What is for this triangle, right? What is my base? This much. And what is my height? This much.
So you can still use 1/2.
Times this times this.
Okay.
Yeah. Now this whole thing is actually, we can find out this thing because this is half of this whole distance. So that's why this was 10, so we did 10 by 2. This thing is a height, which is again half of this whole length. So this whole length was 20, so 20 by 2. So that gives me this height and this height. So base and height. I multiply half into base into height. That will give me the area of this triangle. Yeah?
Okay.
So once I find out the area of this triangle, I will multiply that by 4. Okay? That will give me area of this rhombus. Sure?
Yeah.
Alright. So now you will not like what I am doing now, but I will still do it because you will have it for your reference. Okay? It's there in the video. So now I'm trying to find out the area of this shaded triangle. Okay? So it will be half into base into height. How much my base? This is my base. And how much is that value in terms of d1 and d2? Half of the d1. This part is half of this whole length. So this base is whatever is my length here, this whole length divided by 2, that is my base. What is my height here? This whole distance by 2, d2 by 2. Yeah?
Yeah.
So we have just been able to find out or relate to the diagonal to find out the area of this triangle, but that is not our goal. Our goal is to find out the area of this rhombus. That will be 4 times of whatever we have here. 1 by 2 into d1 by 2 into d2 by 2. So whatever we got as an area for this triangle from this formula, We multiplied that thing by 4, that will give me the area of this rhombus. Okay?
Yeah.
Now play with it. 4 I can write as 2 into 2 into 1 into d1 into d2. This is what I have on the numerator. And denominator I have 2 into 2 into 2. 1, 2, 3 2s. Yeah? Time for the tic-tac-toe. This one gone, this one gone. What do I have? d1 into d2 by 2. So this is a formula for finding out the area of a rhombus. Length of diagonal 1 times length of diagonal 2 divided by 2. That will be your area of a rhombus. That's what I was trying to derive. Okay. That's why I was insisting on going to this route, so that we have a formula derived for us, so that when we have to find out the area of a rhombus, we know what to do. Okay? So area of a rhombus would be d1 into d2 by 2. Yeah? Where d1 and d2 are two diagonals. And the property that we know is d1 and d2 are perpendicular bisector when we talk about rhombus. Yeah? So this is for rhombus. I will not get you stressed out by talking about the formula, how to derive the formula for chi, because you guys don't have to derive it. Okay? I want to save some time, which we'll use for talking about the theorem of congruence. Okay? So that's why I'm not going there. No, take it easy, take it easy. See, as you know, I always say that I'm a simple person. So I don't know any complex concept. Okay? Whenever I'll talk about it, I'll talk in a very simple terms. I don't have that extra intelligence that people have otherwise. Okay, don't worry about that. But we'll talk about this one. Okay? Summary is, I'm just trying to save some time. I'm not going to prove this formula, because you don't really have to prove the formula for your exam. You just need to know how those formulas are relatable. Okay? So we talked about area and perimeter for rectangle, no question about it. We talked about area and perimeter for a square, no question about it. We talked about area of a parallelogram, that is base times height. Yeah? And then we talked about area of a rhombus, which we derived, which is diagonal 1 into diagonal 2 by 2. That is your area of a rhombus. You can just borrow the same formula for finding out the area of a kite also. Okay? Same thing, d1 into d2 by 2. That's it.
Okay.
That's why I was not doing it.
Okay.
Okay? Now, if you have to find out the perimeter of this rhombus, how much that will be? And you know it. So don't even doubt yourself. Yeah. Yeah, you know it. See the picture. Your rhombus is nothing but a squeezed square. Your side, length of the side doesn't change. So if you're talking about the perimeter.
Well, then you can use Pythagorean theorem.
No, you don't
to
need
find
to.
the side lengths.
No, so you know this size. Okay, so when you are dealing with a rhombus, you will, like if you're dealing with a square, you would be given the length of one side. And then you know by the property that all the sides are of same length. Similarly, if you talk about a rhombus,
everything the same length.
all the
So you
lengths
have
are
to
the same.
multiply.
Yeah, you can multiply that by 4. That will be your perimeter. I'm talking about perimeter.
Yeah.
So as soon as you hear the term perimeter, first thing that should flash in your mind is, oh, I'm talking about the length of the boundary. And all the sides are same. It's a rhombus. It's a squeezed square. That's it. Yeah.
And then area, you just do just one side times another.
d1 to d2 by 2.
Yeah.
And remember this, d1, d2 has nothing to do with your side.
Yeah.
This is the other diagonal that you have. Either you can find it out.
You do height.
Yeah,
And you find height.
correct.
Okay.
Yeah? So we talked about rectangle, square, parallelogram, rhombus and kite. How to find. Now in case of a kite, if you have to find out the perimeter, again, perimeter. Oh, you're talking about length of the boundary. What we know by the properties, the bottom two sides are of same length, the top two sides are of same length. If I know this side, I'll multiply that by 2. And if I know one of these two sides, I'll multiply these 2 by 2 also and add them together. That's it. Yeah?
And then if they don't give you that side,
Surrender.
then you use Pythagorean theorem.
Then you Pythagorean. Yes, correct. Because what we discussed was that, okay, these are perpendicular to each other. So if they don't give you this side, and they give you this length and this length,
Yeah.
then you can apply Pythagorean theorem to find out this one.
And then you multiply by 2.
Multiply by 2, that gives you the length of the top two sides. Similarly, here also you'll have some correlation, because again, since you know that this is 90 degree, you know this side, and by some means you know this side, then you can apply Pythagorean theorem again. Yeah.
Yeah.
Alright? Yeah. Sorry, you were saying something. This is clear?
Yes.
Okay. So, and again, the good news is it's only you and me in the class. You can make any number of mistakes if you want. Okay, that's fine. Don't. And again, see, you guys are very, what you call, very reserved. I mean, you guys are the kids in this generation. Okay, we were like rowdy kids. We will not even feel bad about who thinks what about us.
Oh.
What about us? Okay, your kid keeps playing cricket all day. It's okay, no worries. As long as I'm eating food at home, it's fine. You guys are thinking too much. So we were never shy of making mistakes. Okay. I'm not trying to change the generation, but what I'm saying is, be fearless when it comes to making mistakes. All right. So okay. Now the next shape is a trapezoid, the last member of the family of quadrilaterals. What does it say? What is the property that you know about? It can be described in one line.
I know you can make two right triangles. If you can find.
That you can find, but if I have to write an essay on this one, what will be that essay? And again, my goal is to make sure that understanding of the shape is crystal clear. So, how do you describe this shape?
The two side angles are the same, equal to each other.
This angle?
Yeah.
No.
No?
The only one line definition of a trapezoid is it has only one pair of lines parallel to each other and they are not of the same length.
Oh, okay.
So only these two sides are parallel to each other and they are not of the same length, because if they are parallel and are of same length, you will end up having either a rectangle or a parallelogram. And we are not talking about these two shapes right now. So if they are parallel but are of different length. That's the basic definition. So if they become parallel and equal, trapezoid is killed. It doesn't exist. Okay. Now, in case of a trapezoid, so basically you are talking about two sides are parallel to each other and they are not of same length. That means this side and this side are different, A and B. And since they are parallel, that means there will be a distance between them, a fixed distance between the two, which will be the height. Okay? So what is the...
So the height will be same or different?
This height will be the same throughout.
Okay.
That goes true for any and every pair of parallel lines. When you talk about parallel lines, I'm not sure if you have ever seen the railway tracks.
Yeah.
You would have seen, obviously. That was a bad joke. So, bad question there. It's like railway tracks, which will never meet. The distance between the two will remain the same, because that's how the wheels of the train is aligned. Right? They don't keep shifting the distance between them. That will remain the same. So that's how the tracks are also having the same distance between the two. Means the perpendicular distance between the two. That remains same, no matter how far you take your train to. Okay? So, if I'm talking about trapezoid having one pair of parallel lines, I'm talking about this one, these two sides being known to us, and then the perpendicular distance between the two. Okay? So, it tells you the area of a trapezoid is equal to half into A plus B times the height. Okay? So it is area of a trapezoid is sum of the two parallel sides times height divided by 2. Okay? And we can find that out also. Okay? We can prove that. I'm just trying to give you a view of that. Okay? Okay. So this trapezoid, what I did was I picked the smaller side and dropped a perpendicular from here to this one and here to this one. So what we did was we split this whole thing into three shapes: a rectangle, a right angle triangle, another right angle triangle. Okay? And if you have to find out the area of this guy, that will be area of this plus area of this plus area of this. Now area of this guy will be what? This length, which is same as A.
It's not just a rectangle.
It's a rectangle right now. It's a rectangle, correct? So this rectangle's area will be length times width. What is my length here? This side is nothing but A, because we have cut a portion out of it, right?
Yeah.
The whole thing is B, but we are talking about only A part of it. Same. A times the height. Okay? The distance between the two parallel lines. So this is the area of the rectangle plus area of this guy and area of this guy. Okay? Let's say this is X, this is Y. So what we're talking about is X plus Y plus A equals B. Meaning this whole length, this bottom line is a sum of this length plus this length plus this length. That's what I'm saying here. Okay?
Wait, to find the area of those triangles, do we use a formula from the last, like rhombus, or no?
No, we don't have, because rhombus have some certain defined properties, okay? Here, we cannot use that because the problem is, see, this is a trapezoid and this is also a trapezoid.
Oh, so it makes sense.
Yeah,
Because it's
yeah.
not even same.
Yeah. So it has no direct correlation with rhombus. Sometimes it might look similar to that, but can we use that as generic rule of thumb? No. Okay?
So do we use again the 1/2 base times height?
Yep. So you will find out. So that's why I said this length is X, this length is Y. So X plus Y plus this length, which is A, equals the total length of the side. So what I was saying was, we found out the area of this guy. Now we'll find out the area of this guy, which will be half into X, half into base into height, which is H. Area of this guy will be what? Half into base, which is Y, into height. So we have three areas. Yeah, we just split that into three parts. Now here what you see is, you have half, H, H, H common. So here you don't have a half. So if you take half H common, this will become Y, plus here you will have a 2A. Because you don't have a half here and you're trying to take half out. So these two will cancel out each other. So you have a 2A plus this is Y, 2A plus X. Okay? Now look at this one. Y plus 2A plus X. Y plus X plus A is equal to B. So this thing, if I split it into two parts, half into H, I can split this into two parts. Y plus X plus A plus A. Yeah? This 2A that I got here, by taking half H common, Y plus X plus A, I put them together and one extra A. Y plus X plus A is nothing but your length of the line at the bottom. So this became half H into, this thing is B plus A, where A and B are two sides which are parallel to each other. So I was just showing you how this formula is derived.
Okay. So
Yeah.
that formula
Half
is
into,
the same. It like adds up to all the shapes you made.
exactly.
So you can either use that formula or find the area of each shape and just add it.
Right. So given the exam like scenario, you might not get the breakdown, as in they will say, okay, the parallel length of the parallel sides are this much and this much, and the distance between them is this much. So then you have this formula handy with you, which you can apply for doing it. And why I was doing all this drama was to make sure that you understand. See, this is our first interaction with a concept called compound shapes. So far we were dealing with triangles, rectangles, square, rhombus, whatnot. These were all simple shapes, which had their own individual existence. Now if you look at trapezoid, you're talking about three shapes being combined to make a new shape. So this becomes our first interaction with the compound shape or combined shape, whatever you call it. Is this okay so far?
Yeah.
Do you need water?
No, I'm good.
You do? No, I have water, so I can get that. I keep gulping water because my throat keeps drying up. So we looked at the simple shapes and trapezoid. Now, you must be thinking that area of a triangle half into base into height, why are you imposing that on me? Because this was a rectangle and we know that length, this is width. Okay? We can find out the area of this by length times width. Now join the two opposite corners. Okay? What you are seeing is these, again, in any shape, when you shape like this, when quadrilateral, when you join the corner, they are called diagonals, right?
Mm-hmm.
This you can see that optically it is splitting this rectangle into two halves. Yeah? This
Yeah.
half and this half.
It looks like every shape makes triangles.
Yeah, correct. So basically your rectangle got split into half. So if area of this guy was length times width, it will be, if I'm talking about area of this guy alone, that will be half of the area of the rectangle that we were seeing. Half into length into width. But in the case of a triangle, we don't call it length. We don't call this width. We call this one as a base, because this is where it is sitting, this side is sitting, right?
Yeah.
And this is how this is one that is defining how tall it is. So you say half into base into height. Yeah?
Mm-hmm.
So any triangle that you talk about, that will have the area of as half into base into height. I'm using very horrible camel casing right now, but yeah, that is nice. Yeah? Yeah? Half into base into height. So at least you can relate it. This should not, what happens is, right, I mean, you are in an exam, sit in the exam and then you know some formula and then something slips. We start thinking, we start getting worried also at times, right? So that is where this kind of visualization would help, because there is a story that is stitched in your mind. You say, okay, yeah, no doubt, I am clear about it. Now, I just showed you a right angle triangle and I said that, okay, area of a triangle is half into base into height, and you'll say, how do I believe that? Yeah? I mean, see, this guy is okay. This guy is okay. But how about this guy?
It's the same.
It's the same. Half into base into height. This is your base and you'll find out the height.
Mm-hmm.
But there's a conceptual background to it.
Okay.
Yeah? So we'll talk about that. But before we do that, let's look at some more simple shapes and then we'll come to this. Check with mommy if she's worried or not. If she's worried, just ask her to be my student today.
Wait, what happened?
No, I'm saying just keep checking with mommy if she's worried, ask her to be my student today. Okay?
That's just
Yeah.
life.
I mean, see again, since I'm a dad myself, right, so I know how parents feel like, right? Had there been some more students in the class, she would have been more comfortable, but you're the only one. My kids have come back home. They're gone for shopping.
Oh, shopping.
My elder one came from college, so that's why both the sisters went out to do shopping.
That sounds fun.
Yeah, it is, yeah. And unfortunately, I'm the odd one out.
Well,
Okay.
I don't know if you want to go shopping. Do
Huh?
you want to go shopping too?
No, I don't do a lot of shopping.
Exactly.
I get
It's
tired.
like my dad. He hates going shopping.
Yep. Alright, so the next shape we'll talk about is, next simple shape is circle.
And I don't like the circle.
Huh? What is that?
I don't like the circle.
You don't like circle? It's a very cute shape. Let's not worry about it. Circle is all around us. Life makes a complete circle. Your car's wheel is a circle. If I have fan here, that's a circle. So circle is something that is part of life. You can't avoid that. See, even the base of this pen is a circle. So here, what is the property of circle? There's only one thing. So you said that you don't like circle. I'm telling you, it's a shape that is Very easy to follow. Let's say if you talk about rectangle, you talk about length and width. You're talking about all the angles 90 degree, all those things. This is a very simple guy. Look at my face, it's a round circle, right?
Yeah.
So it's same thing. Anything that is simple is a circle.
Okay.
So why I'm saying this is simple? Because there's only one property about this gentleman, okay, that you need to know about. I don't know if it's a gentleman or lady, I don't know about that, but there's only one property that you need to know about, that is the radius. Bigger the radius, bigger the circle, smaller the radius, smaller the circle. That's it. So if you have to deal with circle ever, you only need to know one thing, that is radius. As long as you know the radius or you can derive the radius, you have every information that you need for dealing with circle. And area of a circle is how much?
360?
Area
Oh,
of a
no,
circle.
area
The space.
circle.
Yeah, it's okay. Go ahead. Make
I don't know, I forgot.
pi r
Wait.
square.
Okay, pi r squared.
Pi r square. See, this looks like a pie. Apple pie, banana pie, pecan pie, pumpkin pie, whatever pie you know, right? It looks like a pie.
Yeah.
And why the mathematicians in the ancient time they chose the name pi? Because this shape was resembling with a pie. So they were trying to figure out, how do I find out the area? Okay, if I have a radius of 1, I found some area. They measured it manually. If I have a radius of 2 centimeters, what is the area? They measured manually and they found that one thing that is common between all of them is pi. This is a multiple that is common. This is a coefficient that is common.
Wait, is circumference like the same as area?
No. Circumference and area is analogous to area and perimeter. So when you talk about perimeter, you're talking about the length of the boundary. Imagine this being your backyard shape. You're trying to barricade it. How much of a wire you would need for barricading it is your circumference. And how many plants you can plant is decided by the area. Okay?
Okay.
So area is pi r square. So pi is a universal fact which is equal to 22/7 or 3.14. So it's like when they were doing all the calculation to find out or derive or arrive at a formula, they found that this is a common coefficient that is with all the circles that they were dealing with. So they gave it a name pi because the circle itself resembles with a pi. Yeah. And the value of that was 22/7. Okay. So they got this thing being common in all the circle as a coefficient. They said, okay, what do I name this guy? So they said, okay, let me not say 22/7. They gave it a name pi. It will be easy to remember, relate, and that's how this is a value. This is a constant. Okay. So area of a circle is pi r square, and perimeter is 2 times pi r. So the 2, in case of area, 2 goes on the head. In case of perimeter, comes next to this. Okay. So this is the area and perimeter formula for circle. Now somebody say, okay, find out the area of a semicircle. Okay, whatever is the area of a whole circle, divide that by 2. That will be area of a semicircle. And somebody says, find out the perimeter of the semicircle. Then that is a little interesting. See, the perimeter we are talking about for the full circle, you're talking about this curve length. But if you talk about semicircle, you're talking about half of the length of the curve plus this length, which is 2 times the radius, the diameter. So if you're talking about semicircle, it will be 2 pi r divided by 2. That will give you the length of the entire curve part. Plus you will add, this is radius and this is also radius, or 2 times radius, this is diameter. 2 times r. So you don't have to memorize the formula. As long as you have to visualize it, you'll be fine. Yeah. So this is the shape that I was talking about. So we have covered all the possible shapes, all the possible simple shapes, which will become a base for us to deal with higher degree of geometry. Okay. Now we briefly touched upon what is compound shape. That is where we saw a trapezoid which can be split into a rectangle and 2 triangles.
Yeah.
If somebody says, find out area of this guy. I'm just making it up, okay? Even my grandfather doesn't know the formula for this guy. Trust me. But the catch here is, you can join the corners. And then you will see, we can break it into simpler shapes. I mean, again, I did not do a great drawing. These were like straight lines. So we can split this into smaller shapes, simpler shapes, find out the area of all of them and together. That's it. So compound shape, there's nothing that we need to remember or memorize when it comes to dealing with compound shapes with respect to area and perimeter. You just have to split that into smaller pieces and that should be it. Okay? Now, let's say you would have heard, so all the shapes which has more than one side are called polygons. Fortunately or unfortunately, every shape that we deal with, they are polygons. Because there is no shape that comes with one side. Yeah, it's a line segment or ray. So every shape that we deal with is a polygon. So we deal with triangles, quadrilaterals, pentagon, hexagon, heptagon, octagon, nonagon, decagon.
It just keeps going.
It keeps going. But we don't have to worry about it because I said this is a derivative of the compound shape concept that I was talking about. If somebody says, find out the area of the pentagon, no big deal. I'll just join these two corners. I have a triangle and I have a rectangle. And we know by all means how to find out. Yeah. So this was the jump start. Now things will get a little serious. I mean, so far we were serious. This concept will get a little serious. So there are a lot of things that revolves around triangles. Okay. The whole concept of trigonometry is around triangles. That's why it's very important for us to kind of peel off the onions with respect to triangles. That is where there's a concept, there's a set of theorems that we learn as part of it, which is called theorem of congruence.
Is this like the side angle side?
Exactly.
Side
So,
side?
yeah. So we will not try proving any of those. We'll just make sure that we are crystal clear about that and we'll see how we are using that for some of the basic things that we need to talk about. Okay. So this is where the congruence means something being exact copy of something else. So when we talk with respect to theorem of congruence for triangles, we are essentially talking about the means and methods for finding out how the two triangles are same as each other. When I say same, meaning every property matching, every derivative stuff is also matching, meaning area also matching.
So now we're going to triangles and trig. No, we're not.
We're not going to trigonometry yet. We still have to talk about volume and surface area.
Okay.
So geometry is not done yet, but we'll talk about the theorem of congruence and theorems of or the concepts of similarity, and then we'll go to 3D objects. We'll talk about those ones, and then if time permits, we'll start with trigonometry a little bit, and then the following classes break our head with trigonometry and other stuff. Okay, algebra, trigonometry, and this one, right? In the meantime, you can also look at what are the things that is missing, whatever we covered. If there is something that is missing, we'll come to that. Okay.
Because I took another practice SAT yesterday,
Uh-huh.
and there's some geometry questions, and I took a photo of it, so I was wondering if we reviewed that.
Yeah, you can send it to me. So in the next class, we'll cover those. So let's make sure that. Did you see any improvement with the score or some person closer
There
to
was
that?
some improvement.
Some improvement.
I got a 1180 this time.
Oh, wonderful. That's good. So you're that means you're not sitting on it. You are working on it. So that's how things work, right? I mean, I
My math was like a 620.
okay. Math of 620
Yeah.
out of 800.
Yeah, I think it's 750.
No, it's 800.
Really?
It's totally 1600, right? That's the total score.
Wait, no, it's like reading is 750 and then math is 750.
But no, but that will make it only for 1500. The total SAT is for 1600.
What? Okay.
Yeah. Yeah. So you got 620 in math, that means you're dealing with the concepts pretty well. There will be some fine tuning needed, obviously. Every score has scope for getting better, right? So, theorem of congruence, when you talk about, it talks about what are the means and methods for making sure that the two triangles are exact copy of each other. So you have 4 theorems in total. SSS, SAS, ASA, RHS. When you have two triangles with all sides matching, they have no other choice but to be exact copy of each other. Okay? I'm not proving any of those right now. Imagine you take 3 sides, okay? 3, 5, 7. And try drawing as many triangles you want to draw, okay? Physically. And you try to see if there's any difference that you can find. You'll not be able to. If you have 3 sides known to you, no matter how many triangles you draw with those dimensions, flipping the base, moving it upside down, you will get the same triangle. They will look different. You have rotated some of them, but they'll be exactly a copy of each other. This one says, if you have 2 sides and the angle, let's say you have 2 triangles, this one and this one, 2 sides, this side and this side matching, this side and this side matching, and the angle between them matching. 2 sides and the angle between them matching. Your third side will also be the same. Or the triangle will be congruent. Now imagine this. This length of this side is a function of how big or small this angle is. If the angle is small, your side becomes small. Angle is big, the side becomes big, right? It keeps expanding. Yeah. You have to see my dance, okay? To visualize it. So I'm saying, this length of this side is a function of how big or small this angle is. Yeah? So these 2 sides are same, angles are same. That means if you assume that these 2 sides are not same, that is not possible. If these 2 angles are same and these 2 sides are of same length, by no means you can make this side and this side different. They are the same actually, right? Because if you make the angle small, this length of this side is smaller now, even smaller. Make the angle big, your side's length become bigger. Yeah, third side. So basically, if the angles are same, your third side will be the same. Again, it leans on this, and you will say, okay, fine. So 2 sides and the angle between them being same, congruent. Same way, it says, if you have 2 angles same, so this angle same, this angle same, and the side between them same, your 2 triangles will be congruent. Okay? And this RHS is a special case where R stands for, so A stands for angle, S stands for side. Okay? Yeah? So RHS is a special case only specific to right angle triangle. So R stands for right angle triangle. It says if you have 2 right angle triangles where the hypotenuse are of same length and one of the side matches, then they are congruent. Again, Pythagorean theorem that you know.
Yeah.
So if you have this triangle and this triangle, your hypotenuses are matching and this side matching. Uncle Pythagoras has told us a square plus b square equal to c square. If b and c are matching, let's say for 2 of the triangles, why would a not match? Yeah. So these are the theorem of congruence. Now the next concept is around similarity. What do you mean by similarity of triangles, if you recollect?
Don't they have the same angle?
Same angle, zoom in, zoom out. Okay? You take a triangle, zoom in, zoom out. Yeah? When you zoom in, zoom out, what you're doing is your angles remain the same. This angle remains same. This angle remains same. This angle, and this angle remains same. Only thing is your sides are becoming smaller or bigger. When you are zooming in, you are increasing the side by certain. So that's why you would have seen my camera has a 3.5 zoom. What does it mean? It can expand this object by 3 times of its size. Every side, which is, if it is 1 centimeter, it can expand it up to 3.5 centimeter. That's the zoom. So that zoom is nothing but your scale up and scale down capability of the camera that we're talking about. Okay. Now, and this is the most important ingredient for us to even look at the Pythagorean theorem. So Pythagorean theorem that we have, that is proved based on the concept of similarity. I'm not doing that right now because no point proving the Pythagorean theorem.
Oh, like if you had a small triangle, a small right triangle and a big right triangle, they both still have the same 90 degrees.
They'll have the same 90 degree and their sides will be the same proportion. So this is the thing, okay? So this is the concept that you would want to look at. Let's say these two triangles are similar. Let's say this is A, B, C and this is D, E, F. These two triangles are similar, meaning I'm saying this is angle 1 and this is also angle 1. If this is angle 2, this is angle 2. And this is angle 3, this is angle 3. So these 3 angles are matching, okay? So they are similar. One is zoomed in version, one is zoomed out version, kind of. So the concept of similarity says if you have two triangles similar, then their sides will be in the same proportion. Now look at the matching angles. Similarity always revolves around the angle part, okay? Because similarity by definition says, okay.
So it doesn't matter about the sides?
Right. So, no, it matters, but your guiding principle is your angle. Why we are daring to call these two similar? Because the angles are matching. That's the only reason. So that be our driving force here. So if these two triangles are similar, their sides will be in the same proportion. Which side I'm talking about? Look at the matching angle and the sides opposite to that. For this guy, side opposite to that is AC divided by the matching angle, side opposite to that is DF. Will be equal to second angle, this one, side opposite to that, second angle, side opposite to that. Side angle 2, side opposite to that is BC divided by angle 2, side opposite to that is EF. Will be equal to third angle, side opposite to that is AB. Third angle, side opposite to that is DE. This is what it means. That if you're talking about two triangles being similar, their sides will be in the same proportion, and this is a very commonly coming problem in a SAT exam where you'll be given these two are similar triangles. This side is this much, this side is this much. Find out the other two sides.
Yeah, they love to do that.
Yeah. So this is a very simple concept. There are only two things that you have to keep in mind. One is make sure that you match the angles. Okay. See which angle is matching with whom. And then when you're deriving the proportions, you will look at the matching angle between two triangles and the side opposite to that. Okay? And then other thing is, if you are keeping the sides of this triangle as numerator, make sure that you are not flipping it and say, okay, EF by BC. No. If your top one is triangle A, bottom one is triangle B, make sure that we are consistent.
Because if you mix it up, then it would
it'll be a big mess, and then it'll be difficult to decode actually. While the concept is same, it says sides opposite, I mean they are the same proportion, but which one? That is where the angle tells you the clue. Yeah. So far okay?
Yes.
Now let's look at the three-dimensional objects. There's one more thing that you might want to consider learning. If I am talking about a triangle, I'm not sure if I told this to you or not. If I have a triangle, one thing that you would always observe, the bigger the angle, bigger the side opposite to that. Look at this one. This is the smallest of the triangle, right? Even with my drawing skills, you can clearly see this is the smallest of the triangle. Smallest of the angle in this triangle. See the side opposite to that is smallest.
Yeah.
It's always the same proportion.
How about the top angle? Like that
This-
shows the longest thing, right?
This one shows the longest. I mean, again, my drawing skill is horrible, but yeah, here. This is probably the biggest of the three angles. That's why the side opposite that looks to be the biggest. Let me make it very explicit here. Yeah. I give a right angle triangle. This is 90 degree. This probably maybe 20 degree or something. This is 70 degree maybe. Yeah. See, the smallest angle, side up to the smallest angle is the smallest among the three. And that will be a pattern that you'll always see. Okay. So, this is just an observation thing, nothing to do with any formula. But this is a concept that how exhausted you are right now. Are you okay to look at 3D objects?
Yeah.
Okay, alright. So we'll keep it simple. Since I have already bothered you a lot with the area and perimeter of two-dimensional objects, we are going to three-dimensional objects. And three-dimensional objects are nothing but an extension of 2D objects. Look at it. This is a rectangle. Okay? This is a rectangle. You did not bring a notebook. That is where I have a small indentation. Alright, this one. This is a rectangle. What did I do? I put too many rectangles one after another on the top. Same size rectangle. And that is how it added to the height. If I would have stacked, let's say 500 more pages, that would have been higher.
Yeah.
So, when you extend a rectangle, meaning you add height to it, that is when you come across your first 3D object, which is called a cuboid. Cuboid.
Oh.
Yeah? You pick a square, add height to it, such that, see, in the case of square, your length and width are same, right? What you did was you added height to it also, but you made sure that your height is also same as this one. It's called cube.
Well, no, we also have more sides, right? So if you had to find area, then you have to multiply with all those sides.
Right.
Or
So
not area.
we'll go one by one. We'll go one by one. So I'm just making sure that I'm imprinting the image of these objects in your mind first, and make sure that we have zero doubt about what these objects are, and then we will decode it. We should be able to finish our discussion in the next 30 minutes. We are not going to take more time than that, because it's not just about catching up on a lot of things and then not being able to recollect. Right? So this is called right cylinder. What I did here was, we had a circle, we kept stacking same size circle one after another, like you would have seen bangles and all, right? Too many circles of the same size stacked one on the top of each other, one after another, and what you see is
that a cylinder?
right cylinder. We call it right cylinder
Oh, why?
because it's perpendicular. Imagine if I would have stacked it like a tilted thing. If I had stacked it like this, so this is not making 90 degree with the surface, right? That's why it's called right cylinder. Okay? So this, if you look at the center, the axis of symmetry, this is perfectly 90 degree with the horizontal axis. That's why it's called right cylinder. But whichever way it helps you recollect or relate, it's okay. It's called right cylinder. So the catch here is, all these shapes are 3D objects because it has length, width and height. Length, width and height. So 3 dimensions, length, width and height. When we were talking about rectangle, we were talking about length and width, 2 dimensions. One in this way, one this way. Or you can map it with the x and y axis, 2 dimensions. Here you are adding height, which is going the z direction also. So that's why it's called 3D objects or solids. Now if you have to find out okay, so first thing is what is volume? Volume is the space taken by any object. You have a volume, I have a volume, this guy has a volume, this guy has a volume, and we have a volume. Okay?
Yeah, any 3D object.
Anything, because it takes space. So volume is nothing but the space taken by that object in the surrounding where we are keeping it. Okay? So if you submerge me in the swimming pool, I will displace as much water as the volume of my body. So basically, when you are pushing me in the swimming pool, you are trying to create enough space for me to accommodate in that one. So whatever I need, that much I will displace, right? Let's say if you have 50 kids in this classroom and the exact space is for 50. When the 51st student comes in, he will kick somebody out. Yeah? So we create that space. So basically volume is nothing but the space taken by any object. Now, when we came to the classroom, none of us noticed, but we actually displaced that same amount of air out of this classroom. That's how we could fit in here. If the air would have resisted to let us in, we would have been doing the class outside.
Yeah.
Yeah?
Okay.
So that's the volume part.
Yeah.
Now, how much is the volume? Any symmetric shape that you are seeing here, cuboid, cube or right cylinder, you always look at the area of the base times the height, because that's what is deciding how much space it would take. Had it been just a piece of paper, it would have had almost negligible volume. How much area, how much height we added? Let's say if I start another 5,000 pages on the top of the same size, then the volume of space taken by that will be much more, right? So take the area of the base, multiply that by the height, that is your volume.
So to find that base, you do width times length?
Yeah, so this is the length. Let's say we call this side as length, this time as width, which was a rectangle for us, and we stacked so many rectangles and we added height. So area of the base. So if I'm talking about volume, what I'm doing is area of the base.
Oh, this is what I was talking about, like the big B. Big B means area of the base.
Exactly.
So okay,
Yeah.
that relates.
So here length times width into height. Done deal. So this became length into width times height. If you're talking about this guy, your length, width and height all are same. So same thing, same concept you can apply. Volume would be area of base, which is length squared, times height, which is again another length, equal to the length. So it became length cube. Okay. If you're talking about a right cylinder, same thing, you'll find out the area of the base. Now, if you recollect, area of a circle is pi r squared times height. Volume of cylinder, this is your height. The radius is r. So volume here would be area of the base, which is pi r squared times height. Yeah. So any symmetric shape that you talk about, find out the area of the base, multiply by height. Yeah.
Okay, yeah.
Clear?
Yes.
Now you will keep hearing about different interesting names. Rectangular prism. What is the big deal? Rectangular prism. Nothing but the cuboid. It's just given a different name. It's a prism, right? I mean, if you imagine this rectangle this cuboid as a shape made out of transparent glass, it will be called prism.
Wait, what's the difference between prism and like pyramid?
So there are two different things. We are talking about rectangular prism meaning it's a cuboid which is transparent, which has base as a rectangle and then you have height to it. Okay. So you will volume of the rectangular prism will be the same as the volume of the cuboid. Now you might come across things like this. Triangular prism. So what you had was a triangle extended with a height. Find out the area of this triangle, multiply that by height. That will be your volume of the rectangular prism. Sorry, triangular prism.
Okay. Wait, so then that's a prism, so it's a pyramid. A triangular pyramid.
Pyramid is a little different, right? So pyramid has a unique situation where you have a rectangle at the base, and that converges to become a. So imagine a rectangle here, and then everything tapers down to become a point at the top.
So it's like a bunch of triangles stacking, but it gets shorter.
Keeps on getting shorter, shorter, shorter. So don't even think about triangles. You have rectangles, and they keep becoming shorter and shorter. So at one point in time, your rectangle became so very small, became a point at the top. Okay? So pyramid would be a little different from a triangular prism.
Okay.
Yeah? Now we found the volume of cuboid, cube and a right cylinder. So far okay? There is a concept called surface area. How do you find out the surface area of what is surface area of anything? I do not like this water bottle. What will I color? Not the volume, because volume is the space taken by it. I will color the surface area of the surface. Whatever you are seeing at the top or side, whichever is visible.
So okay. So whatever you see. Area is just like talking about the inside too, right?
Right. So go back to my lame statement. I say English is the mother of math. Surface area of the surface. As simple as that. So whatever you see on the surface. Yeah?
Wait, what's the formula for triangle prism volume?
Same thing. You'll find out the area of this triangle. Half into base
So the
into height.
base. Okay.
Half into base into height. Whatever is the area here. And then multiply that by the height. Simple.
Oh, okay. And to find the base, you do 1.5 times.
Base into height. So there are two heights, okay? One is the height of this triangle, okay? And then the height of the prism. So just make sure that no, we are not mixing between this height and this height.
Okay.
Yeah. Okay. So we looked at rectangular prism or a cuboid, cube, right cylinder, and a triangular prism. We are going to talk about the volume part of it. We need to talk about surface area also. So surface area of the surface, whatever is seen from outside. Now you visualize this one. See, this is rectangle, so this is length, this side that you see is also length. This is width, this side is also width. This is also width. This is also width. Yeah? This is length, so this is also length. This part is also length. This is length.
How about your height?
This is height, so this is height. This is height. This is height. Yeah? Now, when you look at it carefully, modeling the way I have drawn it, we are essentially looking at three pairs of equal sides. Front and the back, side and the opposite one, top and the bottom one. So you're essentially looking at three pairs of equal sides. So you will find out the area of this side, multiply by 2. That gives you 2 sides. Find out the area of this guy, multiply that by 2. Find out the area of the top, multiply that by 2. Yeah.
So you're just finding the area of all these sides?
Yeah.
Or not sides, like these mini shapes?
I would not say mini shapes, I'm talking about sides. So whatever is visible to me, right? This is my front of the cuboid. There is a back of the cuboid also. Side, one opposite to that. Top and the bottom. Right? So what you are seeing here is this. Now look at just this side, okay? Which is looking like a rectangle. The one in the front. If you look at just this one, it's a rectangle. Oh, area will be length times width. This is my length and this is my width, which is height. Length times height. Whatever I get as the area of this guy, I'll multiply that by 2. That is front and back. Look at this one. Oh, this is also a rectangle, but length is W and width is H. So W into H times 2.
Oh, to get both sides.
Yeah. And then look at the top. This is the length, this is the width. So length times width is the area, multiply that by 2. 2 times length times width. So basically from this, I have memorized it by teaching you guys so much, but you don't need to memorize it. You can always just look at the picture and you should be able to draw it. And the wall surface area of a cuboid is is 2 times length into width plus width into height plus length into height. Because you are seeing three pair of triangles, top length into width, this one width into height, and this is length into height. That's what you are seeing here. This guy is even simpler because you have all the sides same. So it'll be 6 times the area of one side, which is 6 times L square. In case of cube, all the sides are same, right? So this is like the dice that we use for playing snake and ladders and all those games, right? So all the 6 sides are like perfect square. Find out the area of one side, multiply that by 6. That's it.
Okay.
This guy, surface area should find out. What do you see? One circle is at the bottom, one circle at the top. So 2 times pi r squared. One area is pi r squared, so 2 times pi r squared. That gives you the top and bottom of it. You are looking at this curve. How much is the curve? I'll show you some strength now. I'll show you some strength. I'm saying I'll show you some strength.
Okay.
So this is a right angle right now.
Yeah, that's a cylinder.
Yeah. This is one circle, pi r squared.
Yeah.
Another circle, pi r squared. These two areas we formed. And this is the height. Okay. What we don't know is the surface area of this curve portion.
And it's not like the rectangle where you have.
So see the stud. You're not see the stud right now. So this curve,
Yeah.
okay, I can open it up to make it a rectangle.
Okay.
Yeah? And carefully, okay? See. This is the height, okay? So when I open it, one side is same as the height, okay? And when I'm opening it, my perimeter or the circumference is opening up to become another side. My perimeter is the boundary, right? The length of the boundary.
Yeah.
So when I opening it up, my circumference is becoming another side. So one is this circumference became the side and this is the height. So my surface area of this guy will be pi r squared plus this stunt.
And you find that it's a rectangle?
Yeah, it becomes a rectangle, right? I mean,
So,
this,
I think I see it now.
yeah. So this became when I opened it up. It became a rectangle. This is my height plus height, which is my one side of the rectangle, and then this is my circumference, which is 2 pi r. How much was the circumference was a function of what was the radius of my circle, right? So this 2 pi r into h. So this became 2 pi r plus h. This is surface area for cylinder.
It's like the thing you drew there, right? So first you find the 2 circles,
Yeah.
and
the
then
curve.
you find the rectangle part.
Yeah, and that rectangle we made it up because there was no intelligence that we had for finding out the surface area of this guy. The only way we could do it was, imagine this bottle, okay? If I have to find out how much is the surface area of this guy, what I'll do? I'll cut it from here. Look at this, you're not seeing my stand. I'll cut it here, right? And then this opens up like a piece of, plastic sheet, right? So that opening up is what you're seeing here. Height times how much it will be. So now it's a rectangle, length times width. Width is my height and this is my 2 pi r circumference. Yeah. So this is again, all that I'm doing right now is just for you to be able to relate to it. Okay, nothing cryptic or complicated. There's one more shape. Actually, there are 2 more shapes that you'll come across, and I'm not going to break it down because that will make it very complicated, and you will start.
Wait, so the formula for the surface area for a cylinder
Is
first you find the circumference.
circumference.
Uh,
So top and bottom circle. Okay. So pi r squared plus pi r squared. This takes care of the top and bottom circle. And then we had the curved surface that became a rectangle, and this rectangle had this height, and this was the circumference that opened up to be another side. Circumference of a circle is 2 pi r times the height. Length times width of this rectangle. My length was 2 pi r. And this is the height.
So wait, do I start to find width?
No, so your width is a derived value, right?
Yeah.
You don't have to find out the width as such. What you did was this. This is a stunt that you will always do. So once it converts to a rectangle, then you know length and width. This part is known. This is a height, right? How much is this? That is getting derived by the fact that you cut open the circle. Oh, by cutting open the circle, this is the perimeter that is what is becoming a side of the rectangle.
Okay.
So if I am cutting this bottle to make it a plastic sheet, the circumference will become the side of the rectangle that is for the sheet. Yeah?
Okay. So you're already basically finding that width.
Yes.
Using the circle. So that's why you wouldn't count it again?
Right. We don't need to because that's a derived value, right? I mean, we will not get the width. We will get the perimeter which I am cutting open to find out the width. That's a derived value. Okay. So this becomes my surface area for this one. Now, there are two more shapes that I will talk about. One is called cone, which will resemble a little bit with a pyramid. The cone and a sphere. Okay. Cone, if you visualize this, cone is made by splitting the right cylinder into 3 equal parts. One part, this is the center one. This one will make it another cone, this one will make another cone. So volume of the cone is 1/3 the volume of the right cylinder. Volume of right cylinder is pi r square into h. Yeah? There's a mosquito who is trying to bother you. Okay.
Is it gone?
Yeah.
Okay.
So volume of a cone is 1/3 of the volume of the right cylinder, which is 1/3 of pi r square h. And this one I will not tell you. I'll just force you to memorize this.
Is it like 1/4?
1/3. I mean, just look at this
For
thing.
the sphere.
No, it will be different.
Oh.
It is 4/3
Oh.
of pi r cube, and this is based on deep calculus concepts which I myself have forgotten. I'm still learning or revising what I learned 35 years ago. So that's why I'm not proving this. You don't have to prove it anyways. But yeah, this is the volume of a sphere. 4/3 of pi r cube. So this gives us a view into geometry, different concepts. What is the breakdown of different shapes and objects that we come across? How do you uncover all the concepts underneath and then try solving it? So this essentially doesn't give us any guarantee that okay, we learn everything. No, it has to be followed by practice, obviously. And I would want you to practice, struggle with it, go wrong, that's okay. And you anyways have my number.
Wait, how about lateral surface area?
Lateral surface area, what do you mean by that?
Isn't there something called lateral surface area?
Lateral is sides. So now look at it. This is the base, right? Now what I would say is you mind some problems and give it to me. Okay, wherever you struggle with it. Now let's look at the compound object concept. Okay. Now let me give you a situation to deal with. In the first glance, it looks like a cuboid to you. Right? I have lens with an. I have a pillar on the top of it. This is pillar is glued on the top of it. Somebody says find out the volume of this 3D object. So when you look at the volume, you will say, okay, what is the volume of this guy plus volume of this guy. This guy is a right cylinder, pi r square h, length, width, height. That will be the volume of this guy. Easy. How about, okay, before I move on, find out the surface area of this guy. You are talking about all the surface area of cuboid and the surface area of a right cylinder. You will not add them. There is a small thing that you have to observe. That is, when you talk about surface area, you will have to discount this pi r square.
Because if you don't see it.
That is hidden, right? That is not on the surface. And you'll have to discount this twice, because even for the right cylinder, you'll not count that guy.
Mm-hmm.
Yeah?
Wait, how about the top though? Top of it.
Top is visible, right? I mean, whatever is visible on the surface, that is fine.
Okay.
Now, you have a situation, you will get a problem like this. That, okay, fine. How about this? You have drilled a hole, a right cylindrical hole in this cuboid. Find out the volume and surface area.
I don't think you even count the cylinder, right? Because you technically don't see it.
No, but when you have to count the volume, let's say if you are dipping this in water, this volume it will not consume. Water will still fill in this place.
Oh, so you still find the volume of both shapes and then
Subtract this one. Subtract. Yeah, because this is inside. You have drilled a hole.
Okay.
So right now if you look at this one, let's say if this was solid.
Yeah. Oh, and the cylinder can be your straw.
Yeah.
So
Yes, here is the straw.
Okay.
Yeah?
So wait, so when would you add it?
So you're not adding it. So imagine this as a you had a plastic thing from which you were trying to create this. So when you will take this piece out, because you don't need this much of plastic, because that is a hollow one. So volume will be volume of the cuboid minus this one. Now when it comes to the surface area, again, you'll find out the surface area of this cuboid as a one thing, but then you'll have to subtract this circle and this circle. Okay? But then you have to add only the curved part of the cylinder.
What?
Yeah, because this is a hollow thing. You can imagine this like a big building where you have a big cylindrical hole in the middle, and if somebody is painting that, they will paint the inside of this cylinder also.
Oh, okay. But you're not gonna do the inside of that cylinder.
Yeah, so you will color this part also. So basically, this is an object where you have a hole in the middle, and whatever the curved part of it, you'll have to find out that surface area and discount this area from the surface, because that is that's a hole. So again, all these we learned about, these are the basic 3D objects. Now when you look at the problems relating to it, you'll find different flavors of it. That is where I want you to solve some problems in a very thoughtful way. Don't rush, don't stress out. If you find some problem, try solving it, and if the answer doesn't match, that means there is something that you probably did not consider. Send those problems to me. That is where WhatsApp will come very handy for you and I to deal with those problems. Okay? I would not have a list of, oh yeah, you solved these 50 problems here. No, nothing like that.
Yeah.
Every problem has its own behavior and character. Yeah? So I would want you to, from now till exam, whatever we learn, whenever you come across some interesting problem, right, send it to me. I will solve it, and I'll send you a recorded voice message saying, okay, these are the things that we have to consider. So that way, when you apply that concept and then try solving it, you'll probably be able to get it.
Okay.
So
I'll send you the problems I thought were confusing on my
wonderful.
SAT I took yesterday.
Wonderful. That will help. So I'll be in a disappearing mode from tomorrow evening till Friday, but then I will still be checking my WhatsApp, and I'll be going to my friend's place. So whenever I get some time in between, I will just look at those and give you some approach so that you can try. Okay?
Okay.
Yeah. This is on this one. Now ideally I should let you go, but I will just take 5 minutes maybe, and then So whatever we have learned so far on geometry, that would be a good starting point for us. We will see if there is some more thing. Let's say I might be missing something, right, on concept level. When you send some problems and then I find that okay, this is something that I missed. So in the next class we'll cover that as well. Yeah. Now this might be looking like a cute right angle triangle, but this is the one that has given birth to the concept of trigonometry.
Oh, SOHCAHTOA?
Yeah. So we'll talk about SOHCAHTOA, you're clear, right?
Yeah.
Yeah. So I'm not going to talk about that. Then there's a concept, so this is 90-degree side opposite, that is your hypotenuse. If you're taking this as angle theta, you know how SOHCAHTOA relates to this. Then beyond this, there's a concept called unit circle. So when you're looking at a right angle triangle, you see that your largest angle is 90 degree.
Wait, the only thing I have trouble with SOHCAHTOA is say like they give you the angle measurement, but and then they ask you to find like a side.
Yeah.
Like
Yeah.
that's what I'm
So okay, so that there's a concept called law of sine and law of cosine. So I'll just give you this formula and then start having it. Sine A by A equal to sine B by B equal to sine C by C. B and C. These are the three sides A, B, C, and this is the relationship between them. This is called law of sine.
Oh, okay.
So if you know two sides and one angle, you can find the third angle. If you know two angles, one side, you can find the next side. Similarly, there is a concept called law of cosine. So this is another formula which says if you have, let's say, two sides A and B known and the angle between them theta known, the third side C square will be equal to A square plus B square minus 2AB cos of theta.
Is this? Do you learn this in pre-calc?
Yeah.
Oh, okay.
So so again, see, whether we learn in pre-calc or wherever we learn, idea is that these are the weapons that we have for dealing with all the enemies that we come across. Okay, so be it anything, right? These are the concepts or the formulas. I mean, I have derived these formulas in the previous class, okay, the pre-calculus class. I mean, I don't take any formula on face value. Okay, that's my mental block. If somebody says, okay, this is a formula, use it, I'll say, no, how? Why this formula came into existence in the first place? And then I decode it, then I will say, okay, now I'm convinced I'll use it. Because my problem is memory. I keep forgetting things.
Oh.
Since my childhood days. So unless I understand things, it will not stay with me. Okay?
Okay.
So we'll talk about that. So when we talk about trigonometry, we'll talk about SOHCAHTOA, we'll talk about unit circle concepts, and then we'll talk about law of sine cosine, complementary angle concepts. That will give us enough confidence to deal with things.
Can we also review the circle, like arc length and stuff? Like I
Yeah,
know we
yeah.
learned in class, but like
Yeah,
really the-
arc length sector. Yeah, okay, fine. So we'll start with that, then we'll go to other things. Okay?
Okay.
So next class.
Okay.
I have a meeting